Welcome back, mathematicians. In this video, we are going to discuss polar coordinates. But before we can really discuss the coordinates, let's start by constructing the polar coordinate plane. In a polar coordinate system, we select a point called the pole. Now I'm going to draw this out, and I'm going to apologize in advance for my poor handwriting, so please bear with me. So I'm going to just randomly select a point on the screen here, and this is identified as the pole. This would correspond to the origin in the rectangular coordinate system. And then we will construct a ray with the vertex at the pole. So the ray can be anywhere, but I'm going to go ahead and choose a ray that opens to the right. And so this ray would correspond to the positive x-axis on the rectangular coordinate plane. This ray has a name, and it is called the polar axis. The polar grid is represented by a series of concentric circles radiating out from the pole. So I'm going to do the best I can to draw this, but you would have circles where the center is the pole. And so this is an example of what it looks like. And so that is your polar coordinate plane. It seems very simplistic, and yes, there are the elements of the polar coordinate plane do correspond to the rectangular coordinate plane. One more time, the pole corresponds to the origin in the rectangular coordinate plane, and the polar axis corresponds to the positive x-axis in the polar coordinate plane. Now let's discuss how to plot a point in the polar coordinate system. A point P in a polar coordinate system is represented by an ordered pair of numbers, which will be r, theta. If r is positive or greater than 0, then r is the distance of the point from the pole. So you can see here in my diagram, I have a point P, which is represented by the ordered pair r, theta, and so the distance from the point P to the pole is a value of r. Theta is an angle in degrees or radians formed by the polar axis. So remember, the polar axis is that ray, and that ray would correspond to the positive x-axis. So that would be the initial side of the angle theta, and the terminal side would be the ray that goes through the point P, and the vertex of the angle would be the pole. We call the ordered pair r, theta the polar coordinates of this point. So one more time, I just want to make sure that we're all clear. R represents the distance of the point P from the pole, and theta would be the angle with the initial side at the polar axis, the vertex of the angle at the pole, and then the terminal side of the angle would go through the point P. Let's use that information to plot these 2 points on the polar coordinate system. So as you can see, I have a polar coordinate plane, much better, well drawn out, and it has identifiable angles around the polar coordinate plane. So first, with each of these, I'm going to identify the pole, which as a reminder corresponds to the origin on the rectangular coordinate system, and the polar axis. And of course, this would be the initial side of our angle. Now for the first point, it's 2, 4 pi over 3. So I'm going to start by going out 2 units along the polar axis. So I'm looking at this concentric circle here, which is 2 units away from the pole. And then I'm going to rotate to 4 pi over 3. So rotating around the coordinate plane, because it's a positive 4 pi over 3, I'm going to rotate counterclockwise until I get to 4 pi over 3, which is located right here in the third quadrant. I'm then going to go ahead and draw my point, which is 2 units away from the pole along that ray. And so there's my point, and I'm going to draw my terminal side of this angle as a ray. And so the rotation here would be 4 pi over 3. And again, the point is 2 units away from the pole along that ray. Let's go to the second point. And for the second point, I will again start with identifying the pole and draw the polar axis. I'm going to go 3 units away from the pole along the polar axis. So it would be this concentric circle here, which has a distance of 3 units from the pole. And then I'm going to rotate negative pi over 3. Now, because I have a negative angle, that means I'm going to rotate clockwise instead of counterclockwise. So I'm going to rotate clockwise pi over 3, which actually puts me at an angle of 5 pi over 3. Now I'm going to go ahead and draw my terminal side for this angle and identify the angle. So this is negative pi over 3. And then I'm going to put my point on the ray 3 units from the pole, which would be right here. Here are two more points I'd like to plot because they are a little bit different from the first two that I plotted. With each of these, I'll start with identifying the pole and the polar axis. In this case, I'm going to go 4 units away from the pole along the polar axis. So that would be 1, 2, 3, 4. And because the angle is 0, the ray, the terminal side of the ray, is actually going to be on the polar axis. So this point would be located right here. Now, when you see 4, 0, make sure that you understand whether you are working with a rectangular coordinate or working with a polar coordinate, because it looks similar in both formats. Next, I have -3, -2 pi over 3. So again, I'm going to draw my pole and the polar axis. I'm going to go 3 units away from the pole along the polar axis. Now notice that r is -3. I'm not going to deal with the negative quite yet. So I've gone 3 units away from the pole along the polar axis. I'm going to rotate -2 pi over 3. This would actually put me in the third quadrant. It's actually going to put me at +4 pi over 3 because those are coterminal angles. So I'm going to draw a ray along, for my terminal side of this angle, along 4 pi over 3. I'll then draw the rotation. So this was -2 pi over 3 for the rotation. And then finally, I'm going to put my point on that ray, which is 3 units away. 1, 2, 3. Now, the only difference here is I haven't done anything with this negative. So actually, I don't have my final answer yet. What that negative represents is a reflection across the pole. So I'm not done. What that means is I'm going to reflect the terminal side of my angle across the pole. I'm going to do this in my bright pink color. So that means that the terminal side would actually now be at pi over 3 instead of 4 pi over 3. It also means I'm going to reflect the point across the pole, so it's going to be 3 units in the other direction along this new terminal side. So the final answer is going to be this point P right here, which is on the terminal side of angle pi over 3. So one more time, a -r actually means you're going to reflect the terminal side of the angle and also the point across the pole. All right, guys, good luck.